Hi dear students, here we have another example. This is going to be a little bit more complicated here in the while factoring, okay? So please pay attention. We have to find again the x-intercepts and the y-intercept of this function. This is 2x to the third plus 2x to the second minus 18x minus 18. So in the first step, we are going to equalize the function to 0, and then I want you to realize that we have a common factor in the coefficients because I have 2, 18, and 18, and I can divide all of them by 2. So 2 is the common factor. So we factorize out by 2, and then we have 2 times x to the third, 2x to the third, 2 times x to the second, 2x to the second, 2 times minus 9x minus 18x, 2 times minus 9 minus 18. But, dear students, we have to factorize the whatever we have inside the parentheses. And look, how many terms do we have? 1, 2, 3, 4. So we have 4 terms. And we can factorize by grouping. Remember that we studied this kind of factoring the last semester. So I'm going to group these two terms because the common factor here is x to the second, between x to the third and x to the second, and I'm going to group these other two because I have the negative 9 as common factor. So I'm going to write like this: 2 times and then parentheses to associate. I am going to associate x to the third plus x to the second, okay, plus, and then minus 9x and minus 9, okay. And then in the next step, dear students, look, I'm going to take out the common factor of these two. So this is x to the second. X to the second times x, we get x to the third. Then x to the second times 1, x to the second. Okay? So x to the second is the common factor here. And then careful with the signs here, because instead of this plus, I'm going to write here the common factor between minus 9x and minus 9, which is minus 9. So I'm going to write here minus 9 as common factor. And then minus 9 times x minus 9x. Minus 9 times 1 minus 9. So as you can see, we have to get the same thing in both parentheses. X plus 1 and x plus 1. So now, look, we have one term here. This is one term, and here we have another term. So which is the common factor between these two terms? X plus 1. So we have, now we are going to factorize x plus 1 because this is the common factor, okay? And now we have 2, don't forget about the 2. You have to carry it always, always. So we have 2 times the common factor, which is x plus 1, times x plus 1 times what? Gives me the first term. So x plus 1 times x to the second. And then minus, because it is the sign that I have here, my x plus 1 times minus 9, and I get minus 9x plus 1. Okay? So we already have factorized this, but careful because look, we have x to the second minus 9. So this is a difference of squares. And we have to continue factoring this. And when we factorize a difference of squares, we get a conjugated binomial as we have here. Okay? So we rewrite 2, don't forget about the 2, and also the x plus 1. Okay? And then we are going to write whatever we get, well, the conjugated binomial, which is the square root of the first term, x. The square root of x to the second, x. And then plus, and then I'm going to, one is with plus and the other one is with minus. And then the square root of the second term, which is 9, 3. And then the same elements but with different signs. So I have x plus 3 times x plus x minus 3. Okay? Once we have all the factors here, we are going to solve for x in all of them. We are going to equalize to 0 all of them. And then I'm going to solve for x in order to get the x-intercepts. Okay, dear students? Now, we have 2. So I equalize 2 equal to 0. And remember that when we have something like this, we omit this part. And then we have x plus 1 equals 0, and when we solve for x, we get minus 1. The second factor, we have x plus 3, then we solve for x, and we get x equals minus 3. And then we have x minus 3, and then we solve for x, and we get 3. And here, dear students, we have 1, 2, and 3 roots. And which is the degree of the polynomial function? 3. So we have to get 3 roots. So we are right. Now, step number 2, dear students, y-intercept. We have to find the y-intercept. And to get it, we are going to evaluate the function in 0. So when x equals 0, y equals what? So we substitute x by 0 in all the places where x appears. And then I get that y equals minus 18. So the point, the y-intercept is in the point 0, minus 18. So once we have the x and the y-intercepts, we're going to plot the points. Okay, so we have minus 1. So here I have one root. In minus 3, I have another root. In 3, I have another root. And check, the multiplicity of these 3 is 1. Okay? And the y-intercept is in 0, minus 18, which is here. And now, in order to plot the graph, I have to remember about the behavior. And I have to focus in the degree of the polynomial function and also in the leading coefficient. I have to check if it is positive or negative. Okay, let's see. If the degree of the polynomial function is an odd number, as in this case, and the leading coefficient is positive, remember, it falls to the left, and it rises to the right. So we're going to have something like this. As it falls to the left, it is going to start here, okay? And as all the roots have a multiplicity of 1, all of them are going to cross, okay? So I'm going to do this. It's going to cross, and then it goes back, cross again in the other root, and then it goes, here it touches the y-intercept, okay? And then we're going to have something like this, and it's going to cross. As you can see, it falls to the left and it rises to the right, okay? And all of the roots crosses. They are not bouncing because you don't have any multiplicity, any even multiplicity. I mean 2, 4, 6, okay? Good, dear students. Let's continue working hard with polynomial functions. Take care, stay at home, and see you later.